This is section 4.1 part B, right triangle trigonometry. When you're using trigonometry, the angle of elevation is the angle between the line of sight and the horizontal when an observer is looking upward. So our angle of elevation would be down here. A person standing down here, they are looking up at the top of the cliff, so their angle is looking up. That's an angle of elevation. An angle of depression is the angle between the line of sight and the horizontal when an observer is looking downward. So if our person is standing at the top of the lighthouse and they are looking from the horizontal down to an object, angle of depression is actually outside of the triangle. But since these two lines are parallel, we know that the angle of depression and the angle of elevation are actually going to be congruent because those are alternate interior angles, and we know alternate interior angles are congruent. So you can actually put your angle of depression up at the top, or you can still put that angle down at the bottom, and it would be the same angle measure. A ground crew worker who is 6 feet tall is directing a plane on a runway. If the airplane is 150 feet off the ground, and the worker sights the plane at an angle of elevation of 32 degrees, what is the horizontal distance from the worker to the plane? Now when you're doing these problems, the first thing you need to do is draw yourself a right triangle. Now with our right triangle, we have a person who is 6 feet tall, and they are looking at a plane who is 150 feet up. Now we're going to take this 6 feet off of the 150 to see what that height is of the triangle, and that's going to leave you with 144 feet, for your opposite side. We know that they're looking up at a 32-degree angle. We want to find the horizontal distance from the person to that airplane. Horizontal is straight across, so we are looking for this side, which is the adjacent side. Now you need to decide which one of your trig functions uses opposite and adjacent, and that would be tangent. We know our angle measure is 32 degrees. Our opposite side is 144. Our adjacent side is x. Now we want to get the x by itself, so we're going to multiply both sides by x so we can get it out of the denominator. This is going to cancel. We're left with x times the tangent of 32 is equal to 144. But we still need to get the x by itself. So if we divide both sides by the tangent of 32, we are going to get an x value of around 230 feet. A hot air balloon that is moving above a neighborhood has an angle of depression of 28 degrees on one house and 52 degrees to the second house. If the height of the balloon is 650 feet, we need to estimate the distance between the two houses. So we're going to let x equal the distance from the hot air balloon horizontally to the first house, and we're going to let y equal the distance from the hot air balloon horizontally to that second house out at 28 degrees. These are our angles. That 650 is the opposite side for both of those triangles. The x and the y are both the adjacent, so we are going to be doing tangent, but we're going to have to do it 2 different times. The first time, our angle measure is 52 degrees. The second time, our angle measure is 28 degrees. Now if we go back a second, if you notice, we originally started here tangent of 32 is equal to 140 over x. To be able to solve it, we ended up over here where x is just equal to 144 over the tangent of 32. If your variable's in the denominator, because you're going to be multiplying and then dividing, we can actually just switch those two values and get the variable by itself. So in this example, because the variable's in the denominator, we can switch here and we can get x is equal to 650 divided by the tangent of 52. On this one, we can switch the x and the tangent, and we can get x is equal to 650 divided by the tangent of 28. On the one on the left, when we solve that, we're going to get an x value of 507.8 feet. On the one on the right, when we solve that, you are going to get a y value of 1,222.5 feet. But that just tells you how far each of them are away horizontally from the hot air balloon. To find the distance between the two houses, we're going to have to subtract those values. And that's going to give us a distance of 714.7 feet between the two houses. If you're asked to solve a triangle, this just means you need to find all of the missing angles and all of the missing sides of the triangle. So if we take a look at this first example, we need to solve the triangle. So right now we need to find angle y. We need to find the length of side YZ. And we need to find the length of side XY. Now finding angle y should be the easiest. We already know two angles in the triangle. Remember, inside a triangle there's 180 degrees. We've already used 90 and 35. So we've already used 125 degrees. So there are 55 degrees left for angle y. Now using a trig function, we can solve for our other sides. So if this is my angle, this side is across from it, so it's the opposite. This side is between the angle and the 90, so it's the adjacent. So that one's going to be tangent, or the tangent of 35 is equal to the opposite over the adjacent. Since we have x divided by 10 and we're trying to get the 10 by itself, we can multiply both sides by 10. So x is just equal to 10 times the tangent of 35, where x is approximately 7. So we know the length of side YZ will be 7. When you go to find the length of side XY, you have two different methods you could use. You could do Pythagorean theorem at this point. A squared plus b squared is equal to c squared, where z is going to be your c since it's across from the 90 and it's the hypotenuse. Or you can do a second trig function. Since we're practicing trig right now, let's go ahead and use trig. We know our adjacent. We're looking for our hypotenuse. So that is cosine. The cosine of our angle is equal to adjacent over the hypotenuse. Remember, if the variable's in the denominator, you can just switch these because you're just going to multiply by z and then divide by the cosine of 35. And we're going to get that z has a value of 8.7. Sorry, that was not correct. That would be 10 divided by cosine of 35 is 12.2. So we know the length of side xz is 12.2. Now I knew I'd calculated something wrong when I got 8.7 because the hypotenuse always has to be the longest side. Since our adjacent was 10, there's no way our hypotenuse could have had a length of 8.7. Let's do one more of these, but this time they do not give you any angle measures. If you would like, we can go ahead and start with the side first. If you know two sides of a right triangle, you can always use Pythagorean theorem to find that third side. Remember, the side across from the 90 is your C. Eight squared is going to give you 64. 11 squared is 121. If we add those values together, we're going to get 185 is equal to k squared. To get the k by itself, we are going to take the square root of each side. When we find length of sides, you need to round to one decimal place or to the tenth position. And this is going to get us k is around 13.5. Now we need to find an angle. You can find angle J first or angle K first. It doesn't matter which one you pick. I'm sorry, L or J. We already have K. If we look for angle L first, the 8 is across from it, so that's the opposite. The 11 is between the angle and the 90, so that's our adjacent. So that means we're going to use tangent. Remember, when you are looking for an angle, you use the inverse. And the inverse tangent of 8 over 11 is going to give us the angle L is approximately 36 degrees. Once you know two sides of a right triangle, you can always find the third by doing 180 minus the first two combined. 90 plus 36 is 126 degrees. So that's going to leave us with 54 degrees for angle J.